let's just jump right in, because today's explainer, it literally sounds like something straight out of a sci-fi novel. We're looking at this fascinating development out of a San Francisco startup called Conduit, and get this. It was founded by a former OpenAI researcher, someone who was already at the absolute bleeding edge of artificial intelligence, who just left their post to build something that feels like actual magic. We're talking about direct thought to text, the drive to make consumer telepathy an absolute reality. They are actively training an AI model designed to read your brainwaves through a simple neural headband. So, it takes your completely silent thoughts and instantly turns them into text. No typing, no speaking, just pure thought translated directly onto a screen.
Okay, so to see how this actually builds into a real-world application, I want you to completely immerse yourself in a scenario. Imagine it's the year 2030. You sit down at your desk in the morning, you slip on a super comfortable headset, and you open up Codex to review the coding work an AI agent was crunching on for you overnight. Now notice what you're not doing. You aren't reaching for a mouse, you're not hovering your hands over a keyboard getting ready to type. You're literally just calmly looking at the screen, observing and reviewing the architecture of what the AI built for you while you slept.
And as you're reading through that code, as a human, you naturally have internal reactions. Maybe you feel a split second of confusion over a badly named plot label, or perhaps a quick flash of annoyance because some text sounds a bit too robotic. Well, instead of you having to physically type out those corrections, the headset reads those natural reactions and instantly translate them into commands. You just look at the screen and think. That's it. The AI automatically starts fixing those exact things, tweaking the code and spinning up new tasks based entirely on your internal cognitive and emotional reactions. You never lift a single finger and you never utter a single word out loud. It is completely 100% seamless.
But let's yank ourselves back from 2030 to our present reality for a second. This highly efficient scenario begs a massive question. Is direct thought to text actually possible right now? I mean, are we anywhere close to this, or is this still just aspirational science fiction? To really grasp the sheer gravity of what Conduit is building, we have to look at the actual feasibility and accuracy of this technology at this exact moment in time.
Well, the answer honestly might shock you, because the core problem of decoding human thoughts into text, it's essentially already solved. Seriously, but there is a catch. You have to be willing to go under the knife. With surgical implants that interact directly with the brain, human patients are currently hitting an astonishing 97.5% accuracy, translating their thoughts to text. So the foundational science absolutely works. Those biological signals can indeed be captured and translated almost perfectly.
And the momentum in this space is just wild. It doesn't stop at basic thought to text. Researchers over at Stanford have actually managed to decode purely imagined speech. And to be clear, this isn't tracking vocal cord movements or anything like that. This is decoding the silent words you merely imagine saying in your head in real time at a highly impressive 74% accuracy. We are already mapping the complex language centers of the mind with incredible precision. The data is there, and we're successfully capturing it.
But here's the thing. Nobody actually wants to get brain surgery just so they can talk faster to a chatbot, right? At least absolutely not in the consumer market right now. Because of that, the real race in the tech industry has nothing to do with surgical implants. It is entirely focused on non-invasive wearables, devices you can just slip on. And the progress on these non-invasive devices is staggering too. Meta recently jumped to 61% accuracy with non-invasive technology without requiring any surgery whatsoever. And the way they did it is so fascinating. They achieved this leap simply by scaling up the data. They literally just threw more data at the problem, and the model's accuracy naturally climbed.
Which brings us exactly to why Conduit is making such waves. They believe we are officially entering what they call the GPT-2 era of neurotech. If you remember how early large language models leapt forward exponentially just by scaling up compute and data, well, Conduit is applying those exact same scaling laws to massive neurodata sets. By aggressively scaling this data, they project that we are not decades away from a breakthrough. In fact, they believe we will likely have wearable, cognitive autocomplete, a device literally predicting and typing out your thoughts in just the next 2 to 4 years.
So how on earth do they bridge that gap and achieve this without drilling into the skull? Let's break down Conduit's core mechanical insight here, because it's a wildly brilliant piece of problem solving. They realize that the raw brainwave decoding doesn't actually need to be 100% perfect on its own. Think of your raw brainwaves kind of like a noisy GPS signal. It gets you in the general vicinity, but it jumps around a bit. However, when you combine that noisy GPS signal with a highly detailed map, which in this case is a large language model, and then you combine it with your on-screen context, the whole system snaps into sharp focus. The AI accurately infers your exact intent based on what you are looking at and its deep understanding of language, perfectly filling in the blanks left by the noisy brain signal.
Okay, let's zoom out for a sec and shift the paradigm, because this completely changes how we should look at personal computing. Right now, everyone in the tech world is endlessly arguing over what hardware is going to replace the traditional chatbot interface. People are constantly asking, will it be voice agents, is it smart glasses, or is spatial computing the definitive answer? But when we look at this core question, we have to realize that the physical form factor of the device was never actually the bottleneck, and it certainly isn't the AI model's intelligence that's slowing down our productivity.
The actual true bottleneck in modern computing? It's your hands. Think about it. You think almost at the speed of light. Your brain is an organic supercomputer capable of processing incredibly complex ideas, reactions, and commands instantaneously. Yet, as a computer user, you're trapped. You are forced to rely on your physical fingers to painstakingly type out those brilliant thoughts at an average of maybe 40 words a minute. The massive bandwidth potential between your hyperfast brain and the computer is completely choked by the physical, archaic interface of a keyboard.
Which brings us to an incredible realization about our near future. By completely removing the keyboard, the mouse, and our hands from the equation, we suddenly unlock that trapped bandwidth. Very soon, slipping on a neural band to seamlessly communicate with all of your devices could become as completely normal and honestly as universally mundane as putting on a pair of headphones before you start your workday. It'll just be a familiar, frictionless part of your daily routine.
And when that transition happens, we get this profound shift in the human experience. I absolutely love this quote from the source material because it hits the nail right on the head for what you should take away from this entire explainer. The AI stops being a clunky intern you have to manage and starts feeling like a sixth sense. Just sit with that for a moment. You're no longer managing a separate external tool, you are radically expanding your own cognitive capabilities. The technology disappears, and the artificial intelligence becomes an invisible, seamless extension of your own mind.
So, as we wrap up our deep dive into this topic, I want to leave you with a final, provocative thought to really chew on. We are currently standing right on the edge of a fundamental transformation in human-computer interaction. The physical friction of the keyboard is about to completely vanish. So, when your thoughts can instantly command your devices at the speed of light, what will you choose to build?